episode of Bell and Gossett Podcast, we welcome Bill Knight, an HVAC consultant who conducted a research study on the effectiveness of HVAC systems, taking into account energy use, initial cost, and life expectancy. For engineers who specify heating and cooling in commercial buildings, life cycle costs shouldn't be overlooked in the specification process. Welcome, Bill Knight. Thank you so much for coming on and talking with me about it for sure.
Yep.
So Xylem, about 6 months to about a year ago, I've been working with Bill very closely. I think we were researching some of the things in the HVAC world, and we worked with Bill to kind of come up with an energy study, if you will, particularly to schools. And some of the systems that we were really interested in exploring, because there's a lot of ups and downs and misnomers on different types of systems, and engineers really have an awful lot to choose from when they go for a particular design, and some like more than others, depending. So what we asked Bill to do is kind of do a study, an energy study, life cycle study, over about 3 to 6 schools and exploring different technologies. So some of those technologies we looked at were water source heat pump, geothermal, water-cooled chillers with rooftop VAV, air-cooled chillers and rooftop units. VRF is another one for the middle schools. And then we looked at rooftop unit and VAV. And then we did which it seems to be very popular as well, is VRF and elementary retrofit. So today what we're going to talk about is a little bit about the study, how Bill approached it, some of his findings, and it's a very encompassing study that really covers an awful lot of things. So I'll tell you what, Bill, I'll ask you a couple questions and we'll kind of go down that road. But can you explain a little bit of how you approached this study? And I mean, it seems like it was I like to call it a milk chocolatey cluster, and how we're supposed to be really diving in there. It doesn't seem like it was a really good straight and narrow to really hit it out. But if you could explain on that a little bit further, it'd be great.
Yeah. So, we were talking about, what's been going on in the school business in particular, since there's so much activity in that area, particularly in our area here in the Southeast with growth and student population. And, there's been a lot of changes and a lot of development in the HVAC business and systems the last 10 years with just general equipment efficiency improvements and the introduction of different system types and new arrangements of existing systems. And we just kind of want to take a snapshot of things that were out there in this area, kind of cast a broad net and capture all this empirical data that's out there. We really didn't want to look at doing a traditional technical energy model like you would do for LEED certification. We've done a lot of those. We were more interested in capturing actual data. We want to go see, what are the major school systems in this area doing? What kind of systems are they putting in? How are they operating in place? And what's been the actual energy performance for them? So, we looked at a group of schools in this area, and we wanted to look at all different systems, as you mentioned. So we looked at everything from VRF to water-cooled chillers, and we looked at schools around that 100,000, 150,000 square foot size, which seems like a popular size. And we just wanted to gather data, and put it all together, look at the operating costs and what it costs to build it, and get that information and stretch it out for 10, 20, 30 years and just see how things are going to look. And that's what we did.
Yeah, it's kind of interesting. I mean, what I really like, to be frank, is I really like the simplistic approach you took. I mean, this thing could have been, to your point, sliced and diced in 6 ways from Sunday. I mean, the reality is, what's the easiest way to take a look at something and compare a number of systems? And we're talking 6 or 7 systems here. So I'm assuming a little bit, but you probably looked at a project start to finish within reason, right? So can you talk us through a little bit of how that worked? Is it just installed cost and then maintenance cost and then utilities, or how was that? How did you go about that?
The thing different about this study, I guess you could say, would just be that we used the actual utility bills, after the building had been in place for a number of years. That first year, is kind of crazy, so to speak. You know, when you move in, you're still under warranty and things are getting tweaked and changed, and the owner doesn't know how to operate the building yet. And so we knew that if you were going to apply this system in this area, that this would be a good indicator of how the building was going to operate over an extended period of time. So rather than, you know, do an energy model with a calculated set of 22 assumptions, we just wanted to use the empirical data of the utility bills. We gathered construction data from contractor pay applications or other information that we could get a hold of on what the system costs were, the actual system costs on the construction project. And then we used ASHRAE data for life cycle cost recommendations, and then even looked at that for different stretches of time, because sometimes things change and buildings get renovated or changed into something different. So we kind of wanted to look at scenarios. Well, if we shorten the building life to the system life, this is what it looks like. Or if we take a traditional institutional 30-year look, you know, this is what it looks like. So, you know, the big thing here was looking at actual data and look at different lifespans.
Yeah, and I mean, based on the type of equipment that was there, and using some of the ASHRAE, and ASHRAE's got that guide, I believe, that tells life cycle and what the useful life of a piece of equipment is.
Yeah,
and which is kind of interesting.
Yeah, and it was based on, you know, it was like not a call-in, but like a survey monkey type thing where people could give ASHRAE their data and they would compile it, and they did that for a couple of years and got a good amount of data. And then they used their traditional data that, you know, the handbook committees had put together over time for system life. So they have gathered a lot more data here recently about system life. Some systems are still fairly new and we don't have a whole lot of data on, but for the most part, you know, that collection that ASHRAE did a few years ago, they kind of stopped it because they thought they had enough information and that technical study time was over. So we tried to use the most recent information.
So let me ask you about that a little bit, because you know, with 7 different systems, was there anything that really just as a surprise or kind of jumped out at you, even if you were to take a slice of time or over the entire project, that was a little bit of a surprise?
Well, you know, I've been doing it long enough where, you know, nothing really shocks me, but it you know, the life of the system, since we looked at different lifespans, did make a big difference on how you looked at it. And whether it was new construction or retrofit, of course, you know, that made a big difference too. You know, the study pretty much came out the way we thought it would, based on past, you know, traditional energy studies and just looking at Energy Star ratings and what we've been able to get Energy Star rated. There weren't a whole lot of big surprises, but the life cycle of the building does matter. You know, if you're an institutional owner and you're going to be in a building 50 years, you know, the system that you choose, it makes it's a major economic decision.
Sure. So I would imagine from a maintenance perspective as well, and how long is that really going to last, et cetera. I mean, you know, some of the things that were surprising to me, and surprising, not surprising, in a little bit there was, you know, one of the things that I've noticed in designs in the Southeast and other areas of the country is that geothermal. And I think we were looking at it at one point and it said something about, you know, I was surprised and thinking, well, geothermal, it's the most efficient system. It should be winning. It should be number one. And it didn't come out that way. And correct me if I'm wrong, Bill, or maybe you can expand on it a little bit, but has something happened with the wells or how it was initially installed or originally designed or something along those lines that really prevented it from being that number one? I mean, it was right up there, but I would have thought that would have been number one as opposed to, say, water source heat.
Yeah, you know, if you look at the results of the study and the graphs, you know, it's clearly the most energy efficient. but the cost of the wells and the maintenance issues there, it pushed it to a close second. It's still, a really good choice, still very economically feasible. It's just that well cost and a lot of the systems were not what I would call a hybrid system. So, there's a smarter way to do it these days. People have figured out you can kind of put half the wells in and supplement, those peak days, so to speak, so you don't spend half your money for 10% of the time. I think as that gets adopted, you're going to see a lot more truly cost-effective ground source heat pump systems. That the well drillers and the technology and the QC on the wells, you get your well life. You're not putting in as many wells, and you just supplement, with a cooling tower and a boiler. That's, we didn't study one of those, so that's probably going to be a pretty good option in the future too. It's just when you look at the most effective system and the second effective system, which were water source heat pumps and ground source heat pumps, the ground source heat pumps were the most energy efficient system, but they were penalized a little bit because of that well cost.
Sure.
Want to learn more about how Xylem is solving water in areas like municipal water, stormwater management, and water treatment? Listen to Through the Water Cycle, our latest show covering all things in water utilities today. Episodes are available to stream or download now in the Solving Water a Xylem podcast feed, wherever you listen to podcasts.
And obviously, in looking some of it too, maintenance cost, and each one of these has their own different scenario of doing maintenance, right? I mean, how the maintenance staff is going to be there, how they can deal with it. Are they staffed to take care of it, say a chiller application, or is it more apt where you have other areas within the Southeast that, the school maintenance personnel may not be equipped to deal with a chiller and may have to deal more so with a heat pump or a rooftop unit. So a lot of those factors seem to really come into play when decisions are being made. I mean, it's very interesting to think about this from a life cycle cost perspective in my mind. And, some of the things that I would say in South Carolina and even the Southeast is humidity becomes a big issue and the amount of outside air. You probably know these. How is that really affected in the schools and the school districts? I mean, do you see a change and a trend on using different technologies to reduce that outside air so that they can reduce their overall energy costs?
Oh, absolutely. The big trend a while back, probably going back almost 20 years really, is the implementation of dedicated outside air systems or DOAS systems. And then what's come into play and what we've really had a lot of success with here recently is cold plasma air cleaning, bipolar ionization, using the IAQ method within standard 62 to reduce your outside air. And then, if you can use that technology in traditional systems like a water source heat pump and get your outside air down to an amount that heat pump can handle by itself, then you don't even need a DOAS system anymore. And then the manufacturers have figured out how to put a very effective reheat system in these water source heat pumps too. And that's a very promising combination that is really just getting implemented, and probably in about 4 or 5 years it's going to be interesting to see how these systems have performed with lower amounts of outside air to limit that, and the air cleaning and free reheat within the water source heat pump, using that condenser water to get free reheat.
That's interesting. I mean, as an engineer myself, not PE by any means, but looking at overall systems and getting the chance to do that. I mean, I got to think a ton of load obviously comes from making sure you have that indoor air quality to the right level, and bipolar seems to be really pushing it and helping that. I mean, I got to think that would help reduce some of the size of the water source heat pump or a geothermal for that matter in tonnage, because you're just not having to deal with that hot, humid air, or not as much. Let me rephrase. and making that overall ownership a little better, right? I mean,
yeah. I mean, you can cut your outside airflow in half and really just have enough to keep the building pressurized, and the air cleaning, takes care of all the contaminants per standard 62. Really does help with, it's really a negative infinity payback, because just from the beginning, it reduces your construction costs and tonnage. So simply by adding these devices, you're saving money on day one.
Yeah, I would imagine that's going to become, especially in schools where, keeping students healthy and getting that learning up for all the students so that they can pay attention, and dealing with that balance of first cost is going to be pretty darn important, I would imagine, for a school district for sure.
Absolutely. And most local authorities and authority having jurisdictions that govern various school districts have accepted, this design philosophy too, using the IEQ method. So it's been implemented fairly widely here the last 5 to 10 years.
Yeah, sure. And I've seen some popularity of it as well. Anything else that you can think of on the report that were really outstanding by any means? I mean, I see a lot of balances back and forth on the install cost, replacement allocation, 30-year or 15-year maintenance cost. I mean, if let's say you weren't a school institution and you weren't really looking at that 30-year cost, but maybe a 10-year cost, do you think, obviously there's a lot of systems, it would move the system around quite a bit because we're really dealing with that life cycle cost? Is that fair?
Yeah. And then what happens there is your really big applied 4-pipe systems, chillers and boilers gets knocked out, and then the owner's got a decision to make between water source heat pumps and rooftop units and VRF of some configurations. And that's your traditional model in smaller buildings and commercial construction. You still see a lot of water source heat pumps in office buildings. So what it does is it just knocks out the bigger systems that you see in institutional buildings of larger sizes, over 100,000 square feet.
Yeah. It seems. I mean, it's amazing how big life cycle can really play on a type of system, and what engineers and owners should be really thinking about when they're making that selection. Sometimes it seems like it can be really easy to go off of a first cost decision, when the reality is really taking that step back and looking at the overall cost for an entire life of that building, or how long that owner plans on holding it, for sure, as an asset.
Yeah, I mean, when you look at the graphs we prepared, I mean, the colors are showing you that the energy costs should really be the driving factor. It's very clear.
Sure. Yeah. No, you're absolutely right, for sure. Awesome. Well, hey, Bill, I wanted to thank you for the talking with me today and talking through some of these design considerations, how we approached it, and even about the bipolar ionization. I think I'd love to explore that at a later date. I mean, I think that's some of the new and up and coming technology, especially implementing that with some of the hydronics and the hydronic designs. That's just going to make these units hydronic, as a system, more efficient and more effective. So I want to thank you for the time today, and we'll definitely be having you back on here for another follow-up for sure.
Sure. Be glad to. Thank you.
I appreciate it, Bill. Anybody that would like to see a little bit more and get a little more detail on the study, you can go to the Bell & Gossett website to take a look at the synopsis. I think it'll be very interesting for everyone to get their opinion and read through this wonderful study that Bill's put together. Everyone, please stay tuned for the next following podcast that is looking to come shortly after this one.